Hello everyone, welcome. So today we are going to resume from where we left last time. So we built our platform quite well. We are in a good shape, I would say. We have a JupyterHub instance where we can spawn our JupyterLab session with some trick and some cool extension. We can deploy an MLflow server on our session and export that to the through the JupyterHub proxy. So yeah, so far so cool and so good. So yeah, I would like to present the topic of today's taking back the schema and the sketches that we drew last time and see what we can do. Especially we are missing one thing. We have everything to track our machine learning models. We have everything to do the compute part, but we are missing quite an heavy tool that is the data management tool. So where we are going to store our data. And since this is a school, we need some easy way to make the students to touch with their hands how this new storage system works, especially the object storage that is the king, if you want, of the cloud paradigm. So distributing data and particularly detaching data from the compute part is the core of what we want to is the core message for the school from my perspective. Okay, so if you have an heavy decoupled software that is capable to distribute compute and distribute data in the very same manner, yeah, this is going to be cool, because you don't have to think, okay, I need this data in this way or in this other way. You just go ahead and drop what you have on the resources that you have. All right, that said, let me just bring back down the music because it's okay, quite too loud. We can go ahead and going into our main business today. So to the tablet, I want to recover a bit where we were, so we can go ahead. So we have a Kubernetes cluster, right, where we put our lot of stuff here. Oh, a lot of latency. Ah, come on, are you kidding me? Let me see if I can reload. Okay, let's see if it's better. Yeah, kind of. So we have this Kubernetes cluster, and inside this we have a JupyterHub instance that we expose. Okay, that we expose, and then we have also the user logging into this app, and after the login is redirected to a JupyterLab instance. This JupyterLab is runs on a container, so I put the Docker icon to emphasize that. And now we are in the situation where we have everything in here. We have all the tools that we need to construct our machine learning pipeline and so on and so forth. What we miss is something that say, okay, now along with this pipeline I also need a place, okay, where I have, oh no, I cannot draw with this latency whatsoever. So let's put the tablet aside. Maybe just the, no, it's not possible. Okay, so let me go back to the old way of proceeding. Arrow in here, cool. So, and then we need a storage. Okay, So here we are going to have, for each one of our students, for each one of our user, a storage where they can put their data. That is actually a Minio S3 object storage. Okay, sounds good. So essentially at the login, this part will be brought up. Okay. And the other part we are going to do today is also the fact that we are going to simulate on a remote machine some kind of message queue. I don't know if I have the nuts symbol here. Probably yes. Let me just check. Okay, meanwhile I found the ML flow that I put in here. Oh, there is also the Minio, cool. So I can put this in here. Yeah, no nuts though. Okay, by the way, we are going to have kind of an object here where exactly this is a message queue where we feed some data into it. That will be our experiment data. So we are going to actually, our data will be images coming from Minio dark matter experiment. It doesn't really matter that is a dark matter physics experiment. What we want is to have some realistic scenario where you want to deploy and read images to do your analysis. Then this message queue will be used by the user. So the user will read this data, analyze in their JupyterLab, and then eventually put the result either in MLflow or in Minio instance, or both, right? So this is the plan. And what we missed today to achieve our goal is setting up an automatic procedure to bring up, together with the user, a Minio instance, and also this part, so the message queue. All right, so why don't we get started? I think we can then switch and take a look at where were we. We were in the situation where, all right, there is our values for the deployment of JupyterLab that looks like this. Values. So we have we deploy our JupyterLab on a local path where we keep all the persistence of our database for the JupyterHub instance. We authenticate and we set the admin users. Yeah, this is quite good already. And then we decide, look, I don't want any init container, but I want to expose this service into our wildcard DNS. We will have a video about wildcard DNS in a second, so no, in a few days, so stay tuned. The message here is that we arrive with this hostname request, and we will be redirected to the JupyterHub instance. SOSC is the name of the school for which we are preparing this tool. Eventually then there is the single user storage that is used for dynamic provisioning of the persistent volume for the JupyterLab session. So JupyterLab session, we are going to grant 10 gigs of persistent disk. So each time the users will log in, they will find this persistent disk. And on the local path, so we distribute all the users evenly on all the nodes. And this makes us able to back up periodically all their data and be safe with the minimal amount, with the maximum amount of IOPS possible. So avoiding a shared file system that we could deploy, but yeah, by the number of the users and the resources that we have, we found this to be more effective in practice. We add some labels, and also we use an image that we built in this other machine, and the image was like this one. So Docker file, yeah, we take the basic TensorFlow notebook with Python 3.11, we install some additional packages, and then we deploy the client for Minio. That's all. And then eventually all our extensions. Okay, good. So we have images, we have our deployment. We grant 4 CPU, well, 2 CPU and 2 gigs of RAM, and the limit for the pod are 8 gigs and 4 core. So we do a bit of overcommitment, but yeah, we won't be in any trouble in any case, because we should have more resources than what we have, what we need in theory. Cool. So the other part that we need, okay, pod anti-affinity, we failed miserably last time. Didn't have time to look at that. Possibly I will have a video where we see together how to set up an anti-affinity from the perspective of the pod to distribute even more evenly the pod from the beginning. Then we can pass other pod configuration. One thing that I want to understand is if I can set also ephemeral storage limit and guarantee here. So if you remember, to do that we need to go to the values. One possible thing would be if storage single user. Okay, let's see what we can do here. Affinity, network. Okay, so network policy, no. We look, okay, no, this is storage, this is the one is persistent. The message is that I want to avoid, yeah, extra resources we can do with this. I want to avoid users to store huge amount of data on var.lib inside their containers, run out of capacity on the node, and bring down all other users on the node. This is something that we want to avoid in as much as possible. So, extra resource, limits and guarantees. So I suppose, okay, let me check. Pod limits storage, and here we should have, oops, Come on. Okay. Femoral. Okay. For scratch space, caching, and for logs. Okay. So we want to avoid this to go west, south. I don't know how you say that, but okay. Single file system configuration for local and ephemeral storage. Okay. Okay, let me see, like this. Okay. Oops. Come on. So request. So for each user, we can go up to the request. 4 gigs is fine, and here are called guarantees, and then there are the limits, and the limits are we can go up to 10 gigs. Okay, so limits and guarantees. Okay, so we set this other stuff, and then we need init containers. Okay, so init containers, oh no, extra containers, no, it's init containers. So let's check, because essentially what we are going to do, you remember last time we bring up on the JupyterLab pod the MLflow server, and then we can access it through the JupyterLab proxy, right? So there is a proxy in here that is responsible to do this and expose the service only to the user that has the right to access. We want to do the same with Minio instance, right? So we want to proxy this stuff, and to do that we take Minio and we deploy this as a pod, as a container, sidecar container to the JupyterLab. This means that we need extra containers, extra containers. Okay, so extra containers, and the list will be pretty simple. So yeah, let me take an example. Yeah, containers, exactly. Sorry. No, I do. Okay. So name, we're going to call it Minio. The image that we want to bring up is the one we find into the documentation of Minio. So essentially it is a container from this kind of image. Resources, well, request for memory, we can keep it with 1 gigs. Yeah, and 1 CPU. Okay, yeah, I'll put it in this way, and the limits are 2 CPU and 2 gigs. Okay, a single instance for the user shouldn't take too much memory and CPU in this case, so it's even too much. But yeah, let's see. So resources, okay, yeah, too far. And then we need some env variables in here. So env or environment, I never remember, but yeah, let's put it in this way. So username and password can be very simple because this won't be exposed to the outside. It will be already authenticated by JupyterLab, so we are free to set this at Minio and SOSC. Okay, then we need this command. Ooh, come on. That is server / data, and then there are the args. Oh, what's the data? It's args. Well, actually, command should be. These are all args. Sorry. So the command. Okay. Let's wait a second. Okay, args. Minio, no. Server data and console address equal this. Yeah, this looks okay. We need then to make data persistent, and to make data persistent we need okay, pod mount volume, exactly, we need volume mounts, that, yeah, that is is there a way? Yeah, it should be a way to extra volumes, to specify extra volumes. Extra there, extra live, stuff. Extra volumes. Yeah. I'm wondering if if I have volume name template also for this one. Okay, let's check. This is Minio storage mount path data. Okay, And then we need to be sure that the volume that we mount inside Minio is created at the JupyterLab session creation. So in other words, I want to associate a storage created here with extra volume and I want to attach this to an extra container. The extra container will be the Minio service that is running in here, so in the JupyterLab pod, and then we want to expose to the outside through the JupyterHub proxy. So the user is authenticated to the JupyterHub. We don't need to protect Minio server, so our object storage in other ways. We just go ahead and deploy the easiest and more stable stuff for the students of the school. So okay, what we missed then, we missed to understand, yeah, 0 to JupyterHub, 0 to JupyterHub, and we need to see setup. I'll see administrator guide, services optimization, customization guide, customizing user storage. Exactly. Okay, configuration. Is there any extra volume? Exactly. Extra volumes, JupyterHub shared. There is no way to create an extra storage in here. Is this possible? Oh. The other option is reusing these 10 gigs. Yeah, I wonder if this is working. Yeah, but you know what? Let's give it a try. Okay, so we go ahead and say extra volumes. Okay, so we go ahead and say extra volumes. Name is Minio storage. Minio.storage. No, dash storage. Okay. And then Minio quad storage, cool. And then here we put JupyterHub, no, Jupyter Minio, and how you call it above, yeah, like this. Username or user server. Well, let's see. Username. Should we try this? Volume mounts. Okay, yeah, just a second, because extra volumes is not inside container, but should be something like that. Yeah, exactly. So extra volume, tac, tac. Yeah, let's see. And voila. Let's upgrade. Okay, export and upgrade. line 94. What we miss? Pod args. So args are a list, so this is good. Environment. Pod. We call it right. Okay. Name Minio root user. Value Minio. Sask value Sask. Oops. Right. Okay. Let me see. Yes. So this should be right. Cannot start any token. So what we added? Extra one, extra name. What is incorrect? Is this a problem? No, this is not the problem. So which is the problem then? Minio que aux amp. Volume mount, extra volumes. Is this the problem? No. Is this a problem? Let's see. Okay. Come on. All right. So, first of all, this should go, yeah, in here. And then there is something at 93. I cannot get what is going on in here. Extra container. So if I remove this, $98. Only. Okay. Okay, the editors, I add them. So substitute each tab with one tab. I don't know how much space is there. For 1, 2, 3, 4. More 4, 8. So 2, 3, 4. All right, let's see. Okay, the mystery is gone. Now we need to understand if the username in that way is digested or not. So let me see, single user, no. Maybe yes, because it's a template that is built, so it might be possible. Yeah, although I suspect that we are not going to have any success soon. Oh, okay, no, they are initializing. So yeah, applied. The image pullers are working, so yeah, quite nice. So take home message looks like we need to check still, but you can pass to the storage in the single users extra volumes that you mount on a sidecar container. So in a structure like this. So you have a pod in the blue box, you can deploy JupyterLab with some service, and then also another sidecar container on the same pod, exposing a Minio object through the proxy. This is the plan, this is working. What we did and discovered and we are going to try is if we can deploy a user dedicated persistent volume claim for user extra volume, and this user extra volume will be templated with a username. So the name that will be pushed to Kubernetes is contain a username that should be compiled by the deployment of the Jupyter Hub. Yeah, if it works, it's cool, and we have only one way to discover it. So let me check if now 100 seconds. So yeah, it's fresh new. Let's try to log in. Finger crossed, and yeah, cookie does not matter. Maybe. Yeah, I need to refresh. Unless, come on. Jupyter Minio Dichangot. You see? We put in the template. Super cool, super cool. So we put in the template this. You see? Put in the template this, and we say, okay, when you create JupyterLab, also create a persistent volume claim named Minio username. And what it does is creating a Minio django. Now we miss, of course, one thing. That is the storage class. Exactly. So this is not going to work unless we manually trick this. So jhub get pvc, edit pvc, what is it? So it's looking for this, but it's not creating that. Am I reading correctly? I think so. So extra volume is for something. Okay, now I see. It works pretty well, but it does not create automatically the extra persistent volume claim. So if I go single user here, we take a look, and yes, we have storage type dynamic. Extra volume will only work if, yeah, exactly, if this already exists, if the extra volume name we put already exists. So I wonder, yeah, I think we are going to need something else. Something else that for the time being can be okay. I create this persistent volume, but yeah, get pvc claim django minus o YAML, and then I copy this. Blah. Okay, and vim, oops, and I do this vim pvc.yaml. Ooh. And then we take, okay, 10 gigs is fine, volume, oops, volume name, no, I don't want this, I don't want, okay, local path, 10 gigs, fine, then, okay, the name we can take it from here, so Jupyter Minio django, and we create that. Okay, release, all this stuff, yeah, we don't need it. Creation test stamp, exactly, persistent volume. Right, so we can do kubectl apply minus f pvc, yeah, pvc. Okay, it's pending, bound, so it's starting. Okay, this means that we need some cron on this machine, for instance, where we pull all the users and we check if the persistent volumes are mounted. Something that we can put in our list. Cron job to create PVC. Okay. Turn image already present on machine. What's going on? Get pod. Timeout. Start my server. Okay, so we are initializing, pulling the image, starting the Minio server, and voila. But Minio is failing, so let's check why. And it's called Minio, so -c Minio. Unable to split host port, invalid port number. Okay, let me check how we pass this. -- console address localhost. Doesn't this makes any sense? Okay, let me bring down this, stop my server, log out, and let's try again. We are close, guys, we are close. So upgrade. So we install again the thing that we need. Come on. Okay. Okay, running 18 seconds. Let's try to log in again. Okay, init, initializing. Running error. Okay. Invalid port number. Able to split host port. Let's try again one more thing. We try this. Look. Okay, now it should work. Come on. Perfect. Log in again. Log in again. Yes, and then let me check. Get that. No. Okay. Then perfect. User line should be at least 3, and the password should be at least 8 charts. Okay. Now we're talking. Now we are talking because Oplam. Yeah. Sosk 2024. Okay. Cool. So hub, stop my server. Log out. And upgrade. Now this is actually cool because we just need to create the persistent volume claim, and I wonder if we can do that with a service account and an init container. So we create the persistent volume claim before starting the JupyterLab session, and yeah, we can do that as an improvement. But for the time being, we are going to create with a cron job our persistent volume claim based on the list of the user to the JupyterLab. But yeah, let's keep in mind that you can fully automatize this with an init container. So we can bring up an init container, apply the persistent volume claim with a service account in Kubernetes, and then we can proceed with the very same values. So the very same values means something like this. Let me check just if, yeah, I switched. Okay. Extra containers, mount this Minio storage, and create and take this extra storage from here, so from extra volumes, right? And look for a claim name that is username. It's pretty useful because you can separate different volume for different users and achieve a situation like this, where you have everything inside a pod. Every user, every student will have its own setup, just like they can do locally with a Docker daemon. So this has a double side effect, right? On one side, it's pretty cool from the automatizing aspect of this setup. So everything comes to life at the moment where the user log in into the JupyterLab. But also on the other side, makes users able to reproduce the very same setup and have an experience of a local machine where they can run and do stuff without breaking any other thing. So okay, applied. So we can try again. I know. So log out, log in, launch server. There was something running. What the? Okay, it's running and stable. That's good news. All right, now it's time to understand if everything worked as expected. You remember we put Minio console into 991. Almost. What's happening? HTTP. Console 9111. Connection refused. What the? User django.proxy 9000. Okay, let me check. There is something I don't understand. Let me try like this. Exposing service is always a pain. Remember how much trouble we had with the JupyterLab? With the MLflow? Yeah, same. So stop my server here. Log out. Log out, sorry. And okay. Let's see. Now it's working. Now if I do tool localhost 9000, alright, we have Minio up running and 911 is working. Then if we do this, we see nothing. Let's check with developer tools. Okay. My loader static. Okay, so there is something. So this is exposing on the localhost. Just out of curiosity. Okay. Yeah, you know what? We can say that is almost done. We need to do this. Credential, okay, we don't need this anymore. We can point already MLflow server to the local. From here I can start an MLflow server pointing to the correctly exposed localhost container. There is some redirect from the proxy to the Minio server that is not working. So let's see what it can be. The other option is installing Minio in this way. So downloading. Yeah, let me try something like this. I just want to be sure that we are not missing something important, right? So if now I launch Minio instantly, make dir data, and I do Minio server. Oh, it's the Minio server console address, exactly. Oh, data minus console address, and I say 92 minus server address, maybe. Oops. Okay. Address. Just guessing. Okay. Now if I go exactly. If I go here and I say 992, no, it's not working either. So yeah, so they are exposing here, but it's not proxying in the correct way. Okay, that's a pity. We need to find out something else, I suppose. Yeah, let's see if there is any other option. Minio server -help address. No. Okay, this is a good exercise to be made. Those Minio behind JupyterLab proxy HTTP. Okay. Minio server URL. So no, I don't think it's gonna work, but let's give it a try. So no. There was something. Yeah, Jupyter. Now I got it. Yeah, so it might be a problem in here, right? So let me clear this stuff. And now if I do something like this, it will bound correctly the localhost. But then I suspect that I cannot use the same syntax that I use for the proxy MLflow proxy server. So I cannot do something like 9002. Yeah, because it's not working. There was a trick for the JupyterLab proxy. Yeah, absolute. Should we try this? Yeah, let's try. Proxy, it was before or after? Absolute and then number of the port. Let's see. Absolute. No, same. Okay, never mind. $404. So yeah, it's looking for a wrong path. So essentially, Minio server is not taught for doing something like this. Minio. What we can do then? Yeah, we have an alternative though. We can expose a service from this interface, and then we can use the wildcard DNS to make it accessible from outside. I don't know if we really care about that though. Okay, never mind. So I think this is a very good point where we can stop and resume on the next live, right? Because I'm debugging this a little bit without bugging you too much, and at the same time I think we have an alternative. So next time we will go with the alternative and discover if it can work or not. So essentially, instead of doing this kind of path, the orange one, we are going to take this and bring it to Kubernetes and say, hello, please expose an ingress per user. Okay, user Minio with the name username plus DNS plus wildcard DNS. Okay, so this is the logic behind that. Yeah, I think it's reasonable. And since it's Friday, I think it's also reasonable to stop here. So just one thing I want to understand. Minio URL path prefix. Exactly. Ooh. No. Okay. Minio browser redirect URL. Okay, let's give it a try before giving up. Ah, come on. Okay. and we are going for this, right? Oops. Nah. Huh. Let's see. Without absolute, it's not working, but because yes, woohoo! We did it! We did it! All right. Pretty cool. Now, now we miss only one thing, but can be solved. We need to understand if the proxy allow to auto discovery for the username, and I think it does. Let me check. User redirect. Exactly. Hub user redirect. Cool. So we solved everything. I cannot believe it. Yeah. So we take this, we go to the values, and voila. So we need to an extra environment here saying name, and the name of the environment variable is Minio browser redirect. Exactly. So here value is is this, but with the next one trick, that is hub redirect proxy. Will it work? I don't know. Let's try this first. Okay. If this works, it might work. Let's see. Stop my server. Log out. Let's put the correct port. It's not this one. It's 9001. So it will be exactly this one. And we do upgrade. All right. Got pod. Let's wait for update to happen. Okay. So it's working. Now log in, launch the server, and come on. Oof. Perfect. That's so cool. Okay. I think you understand what just happened. We created a Jupyter Hub, the user login, launch a pod that automatically instantiates a JupyterLab with 10 gigs of persistent storage, then other 10 gigabytes of storage for a Minio server that will be run as a sidecar container with the username attached. So each time the user log in, this will be automatically set up for the user, and the user can access this Minio server through the JupyterHub proxy, right? Without need for any ingress controller. And in fact, this is my notebook with all the extensions that we have, and this is the Minio private instance for the user. Yeah, I think this is it. So we had in mind to deploy Minio, and it's working. We can reach the Minio server also on localhost here, I suppose. So cool localhost 9000 will be, yeah, pointing to the S3 object storage locally. So we can set up MLflow server also to put to that Minio S3 artifact. Now, one thing that we might want to do is also instantiate MLflow also im through as a sidecar container in the pod. While right now, last time we ran simply MLflow server from here, and then we can reach out on the 5000 through the proxy. Oops, we lost almost an hour last time for a slash. Don't be silly and repeat the very same issue again. So, alright, instead of doing this, we can automatize the instantiation of MLflow server with another extra container here. Another extra container here in the configuration for our JupyterHub Helm chart. Okay, we can set this for next time. Then I leave these two bonus setup for the next live, together with setting everything up from the bottom to the top, this instantiation through GitHub's paradigm. So essentially what I mean by that, what I mean by that is that we have a Kubernetes cluster where we instantiate Flux CD, for instance, and that is a continuous delivery system for Kubernetes manifest and Helm charts and artifacts in general. And this allows us to keep all our installation under a GitHub repository where you can make changes to your deployment through pull requests, commits, and so on and so forth. So once you develop something, it's always good to have this kind of approach to the instantiation. So you stabilize things and you make them reproducible. So this is in fact the idea that I expressed here. So this is the next items, and I think we're in a pretty good shape. The other thing that we still miss is that in this setup, unfortunately, I do not find an easy way. I'll take a look and document myself. I cannot find an easy way for us to tackle this. So the creation of this volume for the username cannot be done automatically. So we kind of need here an additional step, a cron job, checking for JupyterHub users and creating PVC for Minio if missing. So while the PVC for the user container are set, for this other stuff are not. So yeah, that's unfortunate, but I'm sure we can find an elegant way, kind of having a service account for creating stuff and using any init container. That would be already quite good. Yeah, guys, I think we are at 1 hour and a half streaming. I think it's quite good. It was nice. I was afraid not to create, no, not to succeed in creating this Minio setup, but yeah, we did it instead. So congrats. Sorry. So stay tuned, subscribe if you want, and if you like this, we have all other stuff ready to be followed up, and I also creating a video from all these slides where we summarize all the steps that we did, very more concise, that it's always good, and we'll attach this to a playlist. So yeah, thank you everyone. Have a good night, morning, whatever. See you the next time.